All right. Good evening, everyone, and welcome to day one of our bootcamp. And I'll be your host for today. I'll be your host for most of the days. I'm hoping that we'll have some of our guests. Let's say guest lecturers, guest presenters join us in the days ahead as we share together. So tonight, as we're starting, though I'm familiar with some of the faces I can see, I mean some of the names I can see, but can we introduce ourselves in the chat section? Just drop something about, just drop your name and where you're joining from, at least. Just your name and where you're joining from this night. Okay, who's going to be starting? Okay, good. Abubakar Abdullahi, Kwara State. Quadri Shakiru Oriyomi, Kwara State. Oh, I have a lot of people from Kwara State. Dada Kende, Lagos State. I have Chibuke from Lagos State, Sherif from Osun State. Allow Emanuela, Jos Plateau State. That's amazing. That's amazing. Yeah. So people are jealous, but yeah, that's amazing. Emanuela, I'm so happy to see you. Oh, this is Chisom from Plateau State too. Opeyemi from Osun State. Anifat from Oyo State. Abba Anifat. Anifat Abba. I have Tijani from Kogi State. That's really, really nice, and I'm glad to see everyone. And welcome to day one of the bootcamp. We're going to use slides today, but I promise we're going to ditch slides from tomorrow. I am really, really focused on the Anton project that was promised. All right, so welcome to Introduction to Data Analysis with Spreadsheets. I'm your host, Charles, for this night at least. And I will just be taking us through just a few things in about 30 minutes, 45 minutes, we should be done for tonight. So, what's the overview of our boot camp? Guys, don't mind my background tonight. I am okay, good. I can hear the feedback that my background is fine. So we're going to proceed. Overview of what is expected within the next couple of weeks. First, this program is going to be for 6 weeks. We're hoping to round up by the second week of December to prepare for the new year. Then we're going to be having 2 sessions per week. We're going to be having one midweek check-in, Wednesday, Thursday, thereabout, where we're going to check in on our progress, and then we're going to decide what form this will take. But our sessions will be just 2, majorly. We're going to have 2 assignments per week. 2 assignments per week. And our project, we're going to submit 6 projects. 6 projects before we graduate, and our attendance criteria is 75%. You must attend 75% of the sessions. If after the first 4 sessions you did not attend any one, we will contact you and have a word with you to know what the challenge is. In fact, once you miss the first 2 sessions, we're going to reach out to find out what's going on. All right, so that being said, we're going to move on now. It's important to state that this bootcamp is organized by TechVantage Academy, but fully supported by the EduFortress community. If you're not part of the EduFortress community, we're going to make that available. That's where we got the push to do this, and then a lot more in the next year. So big shout out to Edu Fortress. It's currently is being led actively by my sister, and she's doing a very, very good job with that. And here we go. So we're going to start today by trying to understand what is data. Most times when we talk about data analysis, what comes to people's mind is bars and charts and tables and reports, dashboards, But data analysis is not about, it's not even about primarily the dashboards. Dashboard is a very small part of what data analysis is and of what data is generally. And that is the whole goal that, okay, look, have the basics and let's show you the power of spreadsheets. Everybody who has worked in data analytics in any part of the world will agree that spreadsheets are your foundations. Sometimes spreadsheets is what you do 80% of the time for most roles, especially when you don't deal with very big data, when you just deal with data of a company, data of employees. Even Nigerian banks, most of the analysis is down to spreadsheets. So that's how powerful spreadsheets are. You can Google it, research the power of spreadsheets, and you're going to see how far it goes. So we're going to start in a very simple way, something we're very familiar with. Every one of us did computer science at some point, and the question, what is data, is always there. Data, of course, refers to raw facts that consist of sometimes numbers, sometimes figures, sometimes other things. And that's exactly what we're going to be looking at here. That, okay, so what else could be data if we're not talking numbers and formulas? We'll talk about data types, because when we get to using strings and formulas, you will understand why data types is very, very important. And one thing I need to acknowledge before we go forward is that a lot of people here who use data daily, because of course I know some of us, we use data daily. I have someone in this group who is Google certified, like the big Google certified data analyst. And so a lot of things I'm going to be saying here, please, if you feel I said anything that is off, please just track that with me. I don't know everything. Please, it's important that we know that. All right, so what are data types? And that is going to help our discussion tonight. Usually, there are many categorizations, but I just love this two, where we are able to put it down to quantitative and qualitative. First, quality. We all know when we say quality talks about descriptions that are not numerical. Descriptions such as color, such as levels of things like JSS1, the type of job I do, the industry I belong. All these are descriptions of people. For instance, when we say introduce yourself, you tell us qualities like your name, you tell us where you're from, you tell us how many siblings you have, you tell us, you're getting my point. That's qualitative. Now, when we talk of qualitative data, we have the ordinal and the nominal. Ordinal meaning ordered, that is class 1, 2, 3, right? Big, bigger, biggest, that's ordinal, right? Something that can be ordered, that can be put in a particular order that goes from smallest to biggest is ordinal. Nominal refers to something that is just based on preference. Like colors, for instance. You don't really say one is bigger than the other, or one is better than the other. So that's nominal. For example, like I said, test grades for ordinal, because of course we know an A is better than a B, which is of course better than a C. But something nominal is nationality. It's okay. So I don't like that example, but let's just accept it that all countries are equal. Now, let's talk about quantitative data, which is what we're going to be dealing with mostly, where we talk about quantities, where we talk about numbers. And that is down to continuous and discrete. Continuous is numbers that can be divided. Things that involves numbers that can be divided. Let's give an example. I can have one cake, I can have 1.5 cake, but you can't have 1.5 cat. It's either a cat or, for instance, they ask you, oh, how many siblings do you have? You say 2.5. Now, because it can be divided, it's discrete. You can't have 2.5 siblings, right? So those are data types. Now I have a very good example here that will tell us about data types. Look at this cup. I'm just using an illustration. Please, let's confirm that you can even hear me. If you can hear me, if you're with me, just drop a comment. Okay, good. I can see thumbs up. Okay, good. You can drop a comment. Let me know what you're feeling. Let me know how you're doing. Let me know how it's going. Good. I can hear you. Thank you. All right. We're good to go. So let me go back to good. Now, this is a cup. If I want to describe it by quantitative or rather qualitative, I would say this is a cup. That's first thing. It's a cup. This is a cup of coffee. This coffee is hot. You can see the little swivel at the top that shows that it is hot. Then this cup is yellow. It's a mug. It has a saucer. Now, all these are qualitative data. They are talking about the quality. Now, let's talk about the quantity, where we have the element of numbers. It contains 6 calories of energy. It costs $1.5. Okay, the dollar to naira now. This is like okay. I shouldn't convert, right? No wala. It contains 0.5 liters of coffee. Now I've put numbers to it, so that becomes our quantitative data, something that is measurable by numbers. I hope we're able to differentiate now. These data types took me a while, but like I said, there are various data types that you're going to meet, especially if you continue in your search for a role in data and all of that. Now, there's another thing we need to put right. Data analysis, data analytics. Is it the same? Is it different? If it's different, what's the difference? Let's start by defining data analytics. It's the broader discipline that includes data analysis, but also involves applying statistical models, machine learning, predictive techniques, and a whole lot of other things. No, it is not data science, but it involves beyond analysis. It goes beyond analysis into predictive science. So if you really say, if you want to go beyond data analysis, then what you will be learning is data analytics. However, data analysis stays with the data. It's involved in inspecting, cleaning, and modeling data to discover useful information and support decision making. That's where it finishes. It gets the data, cleans it, models it, and gives you insights. That is what data analysis is all about. So in this case, we are focusing on data analysis. We are not going into analytics, though it's a very insightful journey that I would advise anyone to go into over time. Now, data can take different forms. That's another thing we need to know, because it's when you start cleaning data that you will understand that data can take different forms. When we have data that is not in tables, how do you work with it? We have structured data. That's the one we're very used to. Spreadsheets, databases, the ones that we are going to be using mostly. We have unstructured data that is just other things like videos, emails, posts. For instance, many of us will go into what we call web analytics. In web analytics, sometimes the research is not table-based. You may not end up with table, but just, for instance, you're doing competition analysis. Of course, you can scrape some things from the table, but there's certain things you will not get until you relate with data that is unstructured. Then, of course, we have the partially structured, something that combines both data types, both the other two forms of data, such as XML files. That, like I said, web analytics, you meet a lot of XML files, files that have to do with web protocol, right? The same for those who will go into blockchain analytics. You see a lot of JSON files, you see a lot of other files that are semi-structured, and you will have to relate with them too. I'm hopeful that this will just be like a foundation for many people to pursue something really, really spectacular. One thing I can tell you is that every industry is operating data, and that's the next thing we're going to be focusing on once we introduce data analytics again. So what is data analytics? We've defined it as the process of collecting, transforming, and analyzing data. And the key goal is to extract insights for decision making. That's basically what we are going to be doing with this session. So we're going to narrow our scope to just this, collecting it, transforming it, and making sure it can speak to us. Now, what are the types of data analytics or data analysis, as the case may be now? As a data analyst, the data analyst for me is usually, I'm checking my time. The data analyst is more of a storyteller. Let me put it that way. Data analyst is someone who, right, can diagnose, can predict, and a lot more. But I'm going to keep saying that this is not everything. This is just an aspect that I have been able to put together to present to you. The first point, or the lowest form of data analysis, is to be able to describe. That is why I keep telling you, it's not just about the dashboards and all. The first thing is to be able to describe what happened, what has happened. It usually tells the history of data, what has happened. Then we move on to diagnostic analysis or diagnostic analytics. Why did it happen? You're trying to make a connection between two or more variables, two or more entities, to see why is this thing happening, right? Why it is happening is the real key to replicating it or preventing it, right? Predictive, what will happen, is a matter of reading what has happened, why it happened, and then you can begin to say, will it happen again? What will happen, in the sense that what has happened before that we now know why it happened? Are we able to replicate it? That is what will happen. Is there a way we can replicate it? Is there a way we can prevent it? Is there a way we can optimize it? Let me give an instance. If you're given the data of a store over the last 12 months, you want to know what product is selling the most. Then the next thing, you want to know why it is selling the most. And then, of course, you want to optimize it. Are we going to stock more of it? Are we going to introduce it to better markets? Are we going to make sure it is readily in their faces, right? Then the last part is prescriptive. What should we do, right? What should we do? What should we do to make sure it doesn't happen again? For instance, if we're making a loss, or if we're looking at, for instance, COVID-19. That was for me one of the biggest announcements of data in recent times, where every day I was going through pages and pages of health analytics. That was when we found out more about the plagues that have happened in the past, why it happened, how it was solved, and before you know it, the data that points to how to predict it and all of that. Prescriptive. What can we do to make it better? What can we do to replicate? What can we do to prevent? All right. I think our time is really, really, we're gaining time today. I'm like, now, data analysis has a history like every other thing. And the history is just tied to computers. If you can tell the story of computers or computing, you can tell the story of data analysis. Some people believe that computers are a product of data, that the quest to analyze data, the quest to use numbers to explain the world, is how we got to where we are with technology. Well, okay. I might agree. Some might say it is not true. Maybe they say it's the other way around, that it is the quest it is from developing all of this technology that we have the field of data. But early usage of data analysis, you see it in data collections, sensors. They are doing sensors. You know, the time of if you remember the birth of Jesus. Now let's use the Bible as a basis. You, if you're familiar with the story, it was during a census that he was born, right? So that tells you that from time immemorial, people have used data to make decisions. They say, oh, count the number of this, count the number of that, and then for us, that is data. Now, like I said, data continue to evolve with computers. We have the era of statistical softwares like Fortran, that's formula translation or translator, as it may be, Pascal, and a whole lot of programming languages that came up in the 21st century, where even Excel is a product of that evolution. Now we're in a different era now. We're in the era of cloud technologies. We're in the era of big data. You keep hearing big data, cloud technologies, and all of that. That's one of the fields that I feel a lot of us should begin to develop into, because cloud, Web3, this is the future. This is the future of tech, not just of tech, of every economy. Now, one reason why I am a big advocate of data analysis is that it is needed in every field. For many people that I've known, I had a boss, my very first line manager, as it will go. He was the first person to teach me Excel. He didn't sit me down and say, okay, this is Excel. No, I just saw the things he could do. Of course, in education, I could see how he used Excel to manage the school, manage the organization, manage inventory, and I was blown away. And that was the first time I sat down to say, look, I think I like this thing. Right? Now, across every sector, it's data is interconnected and evolving. How do I mean it is interconnected? The person working in sales it has to relate to the guy working in production, has to relate to the guy working in supply chain, right? Who has to work with the guy who is doing customer analysis, who will relate with HR. So it is all encompassing, and one thing that ties all of them together is data. So as a data analyst, like I said, you're a storyteller. You're not just a storyteller. You sort of play a role in every field that you touch. Now, that evolving world, it involves you know, when you applied, we gave a couple of options, but of course there are much more. I have a background in health, so health analytics, health records, and all of that comes easily for me because of the understanding of how the health sector works. And no HR, or otherwise known as people analytics, project analytics. This is one of my best because currently where I work, we do a lot of tracking, a lot of trackers, and this is my current expertise. This is something I can teach you in my dream. Like, I love project analytics, developing trackers, trying to see how budgets work, and all of that. Supply chain. This supply chain, I call it the mother of analytics, because every business deals with movement of things up and down. It deals with movement of goods and services. And these are the guys who do. If there's any part of supply analytics I would love to sit in, it will be supply chain, because that's where some people believe the money is. All right. Education analytics, of course. I'm a teacher, so education analytics come easily for me. I'm able to relate easily with it. So depending on your field, there's web analytics, there's blockchain analytics, there's business analytics. Some people believe this is the real deal, business analytics. If you go on Instagram, for instance, this is the aspect of analysis that they keep advertising. Why? Because people now go to business schools just to learn business analytics. That's how vital it has become. And of course, sales analytics, customer analytics, and a host of all of that. And it's all tied to the same foundation. And that foundation is in understanding the basics of spreadsheets. If you can get it, for me, it is somewhere you can continue to build, and you can get your in a career in data. Now, many of us joining are still young. This is a good opportunity, a huge opportunity to learn what data analysis is all about, data analytics, and generally the world of data. But there are some of us that have stayed 10 years, 5 years in another career, and we're looking to pivot into tech. This is, for me, a very low barrier entry point where you can easily begin to build stature, you can begin to build identity in data. And then that's going to be one of the things we're going to deal with this project, to be able to tell people, to show people, not just that I can do this, but the kind of value that you can bring through that which you can do. So what are the roles in data? The first one we're talking about here, and where our focus will be, is data analysis. And our goal is to just deal with data sets, find those patterns, trends, and insights, and what skills data analysts need. You need skill in SQL, SQL, query language. You need skills in data visualization. Either you can use Excel for data visualization, you can use Tableau, or you can use Power BI. For me, I prefer Power BI. And then, of course, you should have basic business understanding, because everything I've talked about, all the industries I've talked about, is some form of business that involves data. Now, what are the common tools you should know? Excel, or in this case, I will say spreadsheets. Then Tableau, Power BI. You don't really need more than that. But some data analysts are actually very comfortable with Python. Python was something I also got interested in, even before I got to even know about data analysis, because it's one of the easiest programming languages. If you can lay hands on it, if you still have the head for programming, it's a good thing to add. Now, going deeper into roles in data, there's a data scientist. The goal of a data scientist is to develop predictive models. It goes beyond what a data analyst would do, to say, look, I want to create a model and predict what is going to happen in the future. And of course, they use machine learning rather. They are the ones involved in machine learning. And what are the skills here? Python or R language? I always prefer Python, but R is very powerful. Some people believe it is more powerful for data analysis than Python. Well, sorry, I'm just a Python. I just prefer Python because it looks more like English. Yeah, I mean, for me, that's the real reason why I prefer Python. But some people prefer the R language. That's also fine. Now, there's the data engineer. This is where you should pay attention. They are the ones who are in charge of the infrastructure, right? That everybody in data uses. They deal with pipelines, databases, data warehouses, data lakes, and all of that. And what skills do you need? Of course, SQL. You should just prepare your mind to learn SQL. They learn data warehousing. They use ETL tools, and I can tell you that they use some other forms of programming languages. And what are their common tools? Apache Spark, Hadoop, Airflow, and a host of others depending on the technology they are dealing with. Usually, or many of, not usually, but many of the data engineers are also cloud developers, because data warehousing usually involve dealing with cloud, Oracle, AWS, um, Google Cloud, and all the other forms of cloud technology that is available. Then, of course, you see me bringing the business analyst again. This is a role that is as begin to carve a niche for itself, that is coming, removing itself from being a data analyst role into a specialized role that is one of the most in demand right now, because though their tools are exactly the same, and their tools and general skills are the same, but they have deep understanding of business. Usually, like I said, they combine this with maybe an MBA or something in business management, economics, and those kind of roles. I think someone's hand is up. Yes, yes, the session is being recorded. The session is being recorded. I'm hopeful that we'll make sure the replay is available. All right. All right, it's true. Let me check and be sure that we're good. The record is ongoing. All right, so what are the common data analytics tools? We've talked about them, but let me just lay it out. For data processing and analysis, you need Microsoft Excel. You can use, of course, Google Sheets, which we're going to talk about in another session. Why you should use one or the other, or the strengths of these two different spreadsheets. They are the most used spreadsheets right now, though they are not the only ones available, but they are the top in the market. You, as a data, for data analysis and processing, Python or R or both, then of course the structured query language. For data visualization, the two go-to are Tableau and Power BI, because I like Microsoft, and the integration between Microsoft Excel and Power BI. I prefer Power BI. The integration, the use of Power Query especially, right? It makes me to have a bias for Power BI, but Tableau is powerful. Tableau has a very strong community, and it will be good for you to just play around with both of them and see the one you prefer. And then, of course, there's the big data, where you use Apache, Hadoop, and Apache Spark, and the other engines that I know very, very little about. All right. Now, let's proceed. What do data analysts do? It's important because people think you must actually have the passion to sit down from morning till evening, just going through tables and making insights and all of that. I love this guy's description. Brady, he works at Centogene. I found it online, and of course we connected. He said, and I quote, "I like to think of a data analyst as a translator." Remember when we started, I said he's a storyteller. It's someone who is capable of translating numbers into plain English in order for a company to improve their business, because that's the whole goal, right? For improvement. Personally, my role as a data analyst involves collecting, processing, and performing statistical data analysis to help my company improve their product. It's simple. It makes sense. You understand why the offer you bring. Some people, they'll say, "Oh, what do you do?" "I'm a data analyst." No, you're not communicating the value that you bring. Here you can see how this person communicated that role. And that person defines, this was found on a job advert. He said this role will primarily focus on turning data sets into an actionable direction for our newsrooms rather. So he's telling you, okay, you're giving us a direction that is actionable, something that is workable, because somebody is looking at the numbers. All right. Now, what skills do you need? It will be good. It will be a plus if you are mathematically inclined. But even if you're not, don't worry. We're here to hold you by the hand. Like I said, over time, I won't be the only one doing this. I will have a host of people who are ready to become mentors, who are ready to support your journey, even if you're not. You are avat. When you see maths like this, you're scared. But don't worry, and we won't be doing a lot of mathematics. And there's always a lot of workarounds as we're going to be introducing different aspects of spreadsheets. Now, if you can, you should learn a programming language. SQL is I won't say it's a must for a data analyst, but if you know it, it will make your life so much easier. And then, of course, choose one between R and Python. You should keep trying to develop an analytical mindset if you don't have it before, if you don't pay attention to it. Then, of course, data visualization. It's a hard skill you will develop over time as you work with data. One thing I will say before we start going into data visualization, please pay a little bit of attention to typography and colors, so that you're going to become a data analyst, not a babalawo. Some people will combine colors. You think they are doing masquerade festival, right? That's not the kind of data analyst we want to build. Here we want to build data analysts with class, with style, and then color themes are something very important for us that will take a whole session to address. All right. Now, soft skills, problem solving, communication, adaptability. I will talk about adaptability. The data analyst is someone who has not. Someone's microphone is on. Okay, we're good to go. The data analyst is someone who doesn't know what he or she is going to be meeting when you're analyzing data. It is very important for you to know that. You don't know what you're going to be meeting. You don't know what you're going to encounter. So you must be very adaptable. You must be willing to you must be very flexible. That's what it means. And then, of course, your type of data will determine how you will analyze it. The form of data, and of course the KPIs, key performance indicators. What is it that you're looking for? What do you want to know? Right? We're going to get into all of that, but that's the soft skill. You must be very inquisitive, right? Curiosity is something that it's not written here, but please add it to your list of soft skills. And yeah, we have come to the end of our module for tonight.